Alright, so just a couple more examples. We're going to set everything equal to 0, so I've got to move this over here. So I end up with 4x squared minus 7x plus 2, which is equal to 0. And then I'm going to use that quadratic formula. So a is equal to 4, b is equal to negative 7, and c is equal to 2. And we're going to plug those in. So negative b, which is negative 7, plus or minus the square root of negative 7 squared minus 4 times 2 divided by 2 times 4. And negative 7 times that negative 1 is going to be a positive 7. Negative 7 squared is 49. Negative 4 times 2 is going to be negative 32. And 2 times 4 is 8. So if we simplify this, we end up with 49 minus 32 under that radical symbol, which is 17, which is not a square. So we're going to be in a situation similar to the video before, where we're going to need to simplify that. Now 17 is a prime number, so I can't break it apart like I did in the last video. Remember, I factored 12 in the last video and I was able to kind of split that. So this video, or this example, 17 is a prime number. So this is basically as simplified as I can make this answer. So I'm just going to rewrite it as 7 plus or minus the square root of 17 divided by 8. And that plus or minus, that means that there are two solutions still. One of them is the positive version of this and the other is that negative, okay? And that is our final answer. Alright, one last example I want to do with you just so that we have a chance to do one more together. 3x squared minus 6x is equal to 12. We're going to move this over so that we have 3x squared minus 6x minus 12 is equal to 0. Okay. Now if we were doing the factoring method, we would go ahead and factor out that greatest common factor of 3, but since we're not, we can just use what we've got. So a is 3, b is negative 6, and c is negative 12, and that is what I'm going to plug into our formula. So we have the negative 6 plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a, which is 3, times c, which is negative 12, divided by 2 times a, which is 3. And so we're going to simplify this. So negative 6 times that negative is a positive 6. Negative 6 squared is 36. And then we have negative 4 times 3 times negative 12, which gives us a positive 144. 3 times 2 is 6. And if we simplify this one more step, 36 plus 144 is 180. So 6 plus or minus the square root of 180 is 6. Okay, so now we end up with 180 is not a prime number, and so we need to go through and figure out how to best simplify this. Now again, I can leave my answer as this, but it's not going to be the most factored version. So I'm going to come up here and I'm going to try to figure out how to simplify this. So before I rewrite the answer, I'm going to try to figure out some factors of 180. So factors of 180, I know I'm looking for hopefully some that are perfect squares. So I know that 4 would be a factor of 180, and that would leave me with 4 times 45. Okay, but 45 can be factored further, and so we could do it as 4 times 9 times 5, okay, because 45 can be factored into 9 and 5, and so that might help us. So what we'd end up with is the square root of 4 times the square root of 9 times the square root of 5, and so the square root of 4 is 2, the square root of 9 is 3, and then the square root of 5 is not a square, so we would end up with 6 times the square root of 5, which is the simplified way that I can write that. Okay, so I know that's a lot of extra work, but this is a challenge problem to show you that. So what we end up with here is x is equal to 6 plus or minus 6 times the square root of 5 divided by 6. And so if I rewrite that, 6 plus 6 times the square root of 5 over 6, and 6 minus 6 times the square root of 5 over 6. And here's another example where 6 divided by 6 and 6 divided by 6 can both be simplified. So we get 1 plus 1 times the square root of 5, and we get 1 minus 1 times the square root of 5. So simplified, our final answer is going to be 1 plus or minus the square root of 5. And that would be our final answer, 1 plus or minus the square root of 5. So again, just a challenge problem, something that you're definitely going to see in Algebra 2, but I want you to just be prepared for that, and that you've at least seen it before. Even if we didn't get to spend a lot of time on it, it still won't be completely brand new to you when you do see it. So hopefully that helps, and we will go through a few more things next week.